And that brings us to our second method on forecasting model using simple average. So this is the equation. The forecast F sub t plus 1, so the forecast for the next period, will be equal to the summation of all the previous demand that has been realized divided by the number of periods that you observe. So this uses kind of an average method, and let's use this in our example. All right, so we have the first period, and we use that actual demand as an initialization, and then we can start to forecast the demand for the second period. So that's going to be 130 because I have one previous realized demand, so I divide it by 1, right? And then let's move on to the next period, period 3. So now when you calculate the forecast for period 3, I have two realized demands in period 1 and in period 2. So I can sum them up divided by the number of periods, which is 2, and that will give me 142.5. And I can go on to calculate the forecast for the subsequent period 4, 5, 6, 7. Again, at this point, I would suggest that you pause the video and work through each of these lines. Now, so what are some of the pros and cons associated with this method? First, less variability because you're now averaging over several values, and so any spike is going to be less obvious and less prominent than if you were to take the value directly from that time period, as in method 1, the naive method. Second, it uses all the data, so you have more information, and it's relatively easy in terms of computation to evaluate the average value. What do you not like? Well, old data might overwhelm the new data, and we know that old data may not carry the same level of information as the present data. And obviously, if you are going to use all the previous data points, you're going to incur very high storage. So that brings us to our next technique. Here we see that simple average forecast, which is what we introduced in method 2, uses all the historical demands to forecast the next period. And every past demand is really important. But as I argue, maybe not all data points that happen in the past are equally important. So perhaps we can use a moving average method. This is method 3. This averages only the most recent n periods to forecast the next period, and assume that each of the n most recent demands is equally important. So let's take a look at this formula here on the top left-hand corner. So we have f sub t plus 1 equal to a sub t minus n plus 1 up until at divided by n. Here, n will be the n-week moving average. So based on the same example that we have gone through so far, let's assume that n equal to 3. And so we have a 3-week moving average. Here you will see that in order to generate the forecast using the 3-week moving average, I will need to have at least 3 previous data points in order to initialize this technique. So once I have 3 points, I can use that to estimate the forecast for period 4 based on period 1, 2, and 3. So here you'll see that I have 130 plus 155 plus 145 divided by 3 because this is a 3-week moving average. And I obtain 143.33. You can go on and work for period 5 using period 2, 3, and 4 realized demand, and then you can do the same for period 6 and period 7. Here I would suggest that you pause this video at this point and work through each of these observations to ensure that you understand and you can obtain the same value as shown on this slide. Now, so what are some of the pros and cons of this data forecast using the moving average? First, you're able to drop old data, so data storage becomes more manageable because you just need to define what n is going to be. But that could also be a con of this method. First, what is the best value of n? That is a question. Second, as you can see here, you need enough data to get started. As you increase the n, you need more data points to get this method started. And third, you can see that for a given n value, all the data points within this n are of equal weight. And revisiting one of the points that I mentioned in the past slide is that data may have different importance level based on time. So yesterday data may be more important, may be more informative than a data that you observed a week ago. Alright, so this is a summary of the moving average forecast. Each of the n most recent demands is equally important, but as I argue that data points may have different importance depending on how long ago it occurred, so I may want to weigh them differently. So to do that, I introduced to you the fourth method, and this is the weighted moving average forecast. So here, this method weighs each of the n most recent demands differently in generating the forecast for the next period. So for this method, let's take a look at the equation. So we have f sub t plus 1 equal to these terms. C are basically the weighting factor that you need to decide. So say for example, we take n equal to 3, so this is a 3-week window, and I have C sub t equal to 0.5, C sub t minus 1 equal to 0.3, and C sub t minus 2 equal to 0.2. And we can apply this formula and start to forecast our values here. And given that n equal to 3, same as before, I need 3 observations to initialize this method. Once I've done that, I can calculate the forecast value for period 4 based on period 1, 2, and 3. So here I get 0.2, that comes from here, multiplied by 130, and that's this value, plus 0.3, multiplied by 155, plus 0.5, multiplied by 145, and then I'll get the answer 145. Note that whatever weighting factors that you choose for a given n window, they need to sum up to 1. Okay, so in a way, this is like a weighted moving average computation. So we can do the same for period 5 and period 6 and period 7 using the same method. Again, I will encourage you to pause the video at this point in time and work through each of these observations to make sure that you understand and can calculate the forecast for each of these periods. So assuming that you have done that, what are some of the pros and cons for this method? Well, the advantage is that anything or any observation that is more recent takes on more weight. And it's more flexible because you can decide what each of these weighting factors would be. And the disadvantage obviously is I need to decide what is n and the weighting factor. As easy as this example might show, in reality it might not be that easy to really evaluate what is the optimal n and the optimal weighting factor for each of the C.